Hello everybody, welcome to my workbench on our building of our signal generator with dip function. Anyway, in front of you you see the mining machine. I was on turning the transformer, our power supply for our dipper and signal generator. 180 volts, so what's on there is now 235 volts. So we have to tape that off and start a secondary for 180 volts and a secondary of 6.3 volts for the filaments. Okay guys, I hope you enjoyed the last video. This time we will continue with some tests. And I think what is really remarkable about this test is the dip function. What this set has. You normally don't find it on any of the signal generators. Anyway guys, so we'll change the position of the camera and we carry on, okay? Okay guys, on the bench you can see our setup. First of all, I want to tell you something. You know this, I told you in the previous video, this thing blasts through everything, you know, everything. It's absolutely stupid, that is. If you want to realign something with that is very difficult, and signal generator blasts through everything you want to do, so you can't make it a proper adjustment when that happens, okay? Anyway, I had opposite of my bench after several receivers there, so I put one receiver on a certain frequency and I tuned my signal generator. See what the effect was. I could hardly notice anything, so I did hear that he was on frequency, but that was about it, so you hardly noticed it. So there is actually no radiation coming from that signal generator, so I did my job well. So anyway, and what I want to tell more, well, you know, and some of you do know, when you have to realign a receiver. That can be an arduous task, and you know that. And I'll take for instance my example frequency 3.5, and you have an IF frequency of 455. You add 455 to that 3.5 megahertz, and then you end up with 3.955. Yeah, that will be your local frequency oscillator, where you should be at for that reception frequency of 3.5. Just imagine this is now our local oscillator. Normally said you don't know where that local oscillator is at, so you want to know that, you want to find out. We're going to use this to find out which frequency is on, okay? And to make you to believe what I'm saying, we are going to put on this signal generator, yeah, and let them warm up a little bit. Yeah. I will change the position of the camera so that you can see and make sure that we have that nicely in view, where that frequency is off. With that, hold on a sec. I'm making myself my life difficult here. I get that chair out of the way a bit. So I have to be careful I won't damage anything. So there we go, go higher. I'll zoom up a bit. Yeah, that's it. Well, that lead is in the way, isn't it? Let's put it out of sight a bit. hopefully it, come on, stay here. Now stay there. Okay. Yes, does he stay? Yeah, he does. So have a look, guys. We have we're not having a plain fluid view. Now we have. So focus. Well, we'll go a bit closer. You can see better. Okay. Play focus again. Now again. You can see now the frequency as 2785. Let's put it at 3.5 for that set. Okay. There we go. And you see that is about it. 3.5 megahertz. 3. Now see, it's not. Sometimes it happens. You have sometimes your signal generator put you at the test 3.5. You can see that. Okay. Now we go back to our original position. Okay. You know now there's 3.5, yeah? Okay, we go back. I zoom out again. And I will refocus. Okay guys, what we're going to do next is to do an interference reading. And we're going to do that with our signal generator and our grid dipper. Okay, we're going to do that reading. Okay. What we're looking now for is the dip of the meter. So I switch that grid dipper on. You see is that the deflection is 0.6. We find out the deflection. Have a look. That is our deflection for that frequency. Yeah. That is the deflection, resonance deflection of. So the resonance coil capacitor is in resonance now with the frequency what is coming off this signal generator or presumable IF oscillator. Okay. Now we want to know with our signal generator. We don't know the 3.5. The signal generator. He's going to tell me what the frequency is. So I'm going to put on my signal generator. And you can see the deflection is even worse now. We have to go back up with the frequency. When it gets there, have a look. You can go past it. He goes past it. And then we are on the same point as our deflection was from our IF oscillator. Okay. What we're going to do now is to switch off our IF oscillator at 3.5. He's gone. Now we're going to reposition our camera again. Hold on. I'm in a tight spot here. We have a chair here and between, so I can put up the camera again. And he's going to tell me what frequency it is. I zoom in. And my signal generator tells me now what frequency it is. 3.502. You can see that for yourself. 3.502. There's no cheating. It's just what it is. So I go back again. I go back. So you can see our signal generator still off. This one, that would represent our IF frequency. And this one is telling me what frequency he is at. We saw previously he was at 3.50. And my signal generator tells me is 3.502. So he tells me exactly where the frequency is. Mind you, I didn't put down, this represents a value, that is about, let's have a look, 3.5, that's what I would say, 55. He's at the 55 mark. So and on that scale I have to mark all the frequencies down from 20 to 75. So at 55 it should be at that frequency of 3.502. That's what my signal generator tells me, and that is correct because you can see that on our meter. So our dear friend what wrote me his comment, well, thank you for that, my dear friend. I can assure you you are in good hands. I know what I'm doing. So anyway, after so many years you know what you're doing. Well, you talked about feedback loops. My dear friend, let me tell you something. If you start a feedback loop on an oscillator, you are in agony city. And I'm going to try to explain that to you. What you have to do is make sure, to make absolutely perfectly clear, that you have your frequency oscillator from your signal generator, that it is stable. It is stable. It can vary 1 kilohertz or something like that. That happens. You put them on and it just jumps 1 kilohertz, but this 1 kilohertz is nothing. And an aligning procedure is that nothing. Okay? But don't start feedback loops. Absolutely not. It is the thing you should avoid at all costs. And you're talking about 1 microvolt or something like that. That's more or less the reason why that happens, because the signal is too strong on the attenuator. So that's why I put in place 2 cathode followers to reduce the signal. So I just did a coupling on the anode, a light coupling, 150 picofarad, something like that. So and then onto the cathode follower, and from the second cathode follower onto the attenuator. Yeah. And then you have a small enough signal to put on there, and you have no creeping frequencies or signal or whatever along the switches or whatever. So I tried that out in the past already. Anyway, guys and gentlemen and our dear friend, don't start feedback loops. But the only you have to do is make sure you have an oscillator who is stable. That's the only thing, and you reduce your signal onto your attenuator. And if you use the grid function to it, you can do that what I did just now. So anyway, guys, gents and our dear friend, thank you again for your comment. Just well, be careful if you build something. Don't run after sayings what people do. So some people are just parrots. They're just yakking away. They hear something and they take it to themselves, and they can't really have any understanding. Sometimes totally no understanding what they're talking about, and they just parroting away what they have heard, and they don't have no experience or whatever to justify what they're saying. Okay. Anyway, my dear friend, hopefully you enjoyed this little piece, and I showed you something here. So we go on with our build, go on with our making of our transformer, getting the power supply into place. And after this we have done that all, I will put in, excuse me, yeah, we put a receiver on the bench, and we will use this signal generator to verify our RF oscillator, or local oscillator from that receiver. This signal generator is going to tell me what frequency he is at, and the book it will tell me how to align this receiver. It will tell me exactly what frequency he has to be on, so that we can determine with this sequence generator and dip function, and then we know exactly where he is at. Just told you he jumped 1 kilohertz. I'll show you. Hold on. That happens. Let's have a look. There you go. He was 3.502 and now it's 3.501. Actually, he's been there for a couple of minutes now. Well, he stays there. Okay, you can see that. That is what happens. That is probably also because of he's not warmed up properly. That can happen. There's always the reason that's why you should always warm your equipment up, at least for a quarter of an hour or something like that, and not start it off like I did just now. So guys, I will stop the video now. I will carry on with my doings, and I come back to you, okay? Okay guys, you can see I'm on to 180 volts secondary of the transformer. Yeah, it'll take a little while, so I think in a couple of hours I will have every turn on there, including our 6.3 volt for the filaments, so maybe I can assemble the transformer and we take it from there. So guys, I will shut it down again. There's not much to see, is there? So I'll see you later. Hi everybody, welcome back again. Yeah, you can see on transformer I finished him, put some insulation tape around it. So we have here our primary. We have here 180 volts, and this is a 6.3 filament voltage. So we're going to put them together now. It's always very important how you start this off. Just get this package of metal in there. It's e-metal, they call that. So we have a look. Hold on. Yeah, so the first one has to go that way in. So say this is the bottom. There we go. The next one will be underneath here. The small one goes underneath. So but we go on with that one. And you put the metal in that transformer. That's the way you make transformers, okay? Get them in. You do that on your own time, so should be okay. Yeah. Oops. Just make sure that they are in the right place. Otherwise you have a double. You have to be careful with that also, that you don't put in doubles. Well, you notice it in the package straight away, so there will be a space between it. So you have to look at, but it is further on, you can have a look at that. If that happens, so you have to control that. By the way, it is important that you put as much metal in there as possible. We're sticking together though, because it has to do with the hum, what the transformer will produce. So if you have too little metal in there, and that package is not as loose in there, this transformer will hum like mad. So there's always the last two, you have to hammer them in there, literally with a hammer, so to get no air space between those plates. If you have airspace in between it, that thing will hum like mad. So, and this core is about 20 watts. And for those who are interested, you have 6.3 at 2 amps. Then you can calculate how much voltage that is. And we have about 40 milliamps on 180. Yeah. And then you multiply that together, or add it together. You have the voltage that is taken up by secondary, and then you multiply that voltage times 100 and divide it by 90, and then you have the voltage out what has to go in, because there are always losses in there. I say 90, but when in the real world I will just divide it by 70, not by 90. And that will gives me higher current on the primary, a higher voltage. So it has to go more in than that comes out. So you have to put the voltage in to get it out. So if it is not there, you can't say, well, it takes, for instance, 18 watts. I put 18 volts in, then I get 18 volts out, and that's not the way it works. But you have probably put 25 in to get 18 out. So I have to do the calculation to be exact with it. So that's how it works, guys. And it's very boring what I'm doing now, so you can see that. I'll keep on for a little while, for a little bit. You can see him grow. It's still early in the morning. I think it's about 8 o'clock or something like that. On Friday, so I have to get the box also in order, so I have to do that as well. I have to mount that transformer. I have to construct this power supply on the whole. So I get the rectifying done, the diodes, I get our capacitors in there, our electrolytic capacitors, to smooth the voltage. There's always a ripple there, so we have to smooth that out. That's how that works. So I think I'm going to use 3 electrolytics, one of 10, one of 22 and one of 47 or something like that. So there will be plenty of storage space for electricity. So the ripple will be gone. So the first one gets 10 microfarads, sorry. The second will be 22 microfarads, and the third one will be 47. And I'm overdoing that. I really overdo it then, but I want to hear any hum out of it. So, well, if you do it right, okay. So it's just it's a matter of one more capacitor. What will that be in money? So I think €4 or something like that. So yes, you can achieve quite some result if you put your mind to it. You see this, it's very tight to get at this point. You get them in, so that's why the insulation tape is there, so you don't damage the wire. So if you would put this label in there and you would make a scratch on the lacquer, then you could cause a short in those windings. Consequently, that the transformer would go up in smoke. So maybe to draw a high current, and it won't take long. It would be super hot and it would just burn out. Okay. Having said that, you don't have to be afraid of overdoing it with this transformer. I have some experience with transformers. After all those, I think. So you have a look. You can't get them in there. There he goes. Very tight. You have to have some experience with that. So transformers can be get really hot. So you have to calculate very carefully, and you have to calculate them on 70%. So that's the most safest thing to do. Calculate them on 70%. And then you have more metal in there than copper. The more copper, the more metal, the less copper that goes in. So that's the way it works. Anyway, guys, if you have a sheet of wire, and you find the how we call that? You find the values on there, on current, and it will be given to you. And you have to bear in mind this wire, for instance, can have about 40 milliamps. This thickness of wire. This says 0.15 millimeters, square millimeters. So that gives you 50 milliamps. You can add about 10% to 15% to it. That is what the wire can have on current. So your bit will be about 65 milliamps can go through this. So without heating the wire up excessively. So there is some leeway in the wire. So for instance, this 1 millimeter, you can have about 4 amps max. So we're going to use 2 amps. So I didn't have any 0.8 millimeters. So I grabbed that one and put that one in. So I have to get a whole new spool of this wire. It sets me back about 150, 160 euros. So I don't feel like it to have that. So I don't feel like it. So that's a lot of money, you know. And I can do it 1 millimeter. I'll do it with 1 millimeter. Okay. Okay, guys. So far so good. I'm going to shut down the camera again, so you saw how it's going to look. So we have to get more on there, so at least that whole stack will probably go in. So and then we wire everything up. So I'll see you then when I'm finished. Okay. Okay, everybody. I got now to the point where I said to you, I have a couple of those lamels too much. They have to go in to get the stack very tight. So I'm going to do that on the bench because I will damage my meters or whatever. I will do that on the floor with a hammer and a block of wood. This I put on the floor, on my tile floor, so I don't hammer my tiles to smithereens. Put that on there, get my little piece of wood. See, that's a small one. Where is he? Where are you? Okay. Oh, there it is. I'll get my hammer. And see, that is the way you hammer them down. So I'm going to do that on the floor for a moment, so I can show you. Hold on. Okay, you can't see it, but you will hear it. Okay. Again, it's not a very big hammer, so a small one. So don't be excessive and be careful. That's all. So I put it on the board. So I start hammering away. Have a look at it. Okay, a bit more. Now we are there. Then we get it on the side a bit, on that side a bit. There we go. There we go, guys. He's in. Getting old. Okay, we have an opening on the bottom here, right there, so we have to put them in. There's about 3 of them. I think I put them in. That's the first 2, we're going to get the third one in. Let's have a look. There it goes. Let's take that bit of wood. There we go. Put them on the side. There we go once more. Now we can inspect the sides. It's not completely down. So. Is he down? Is he not down? Yeah, we're missing one on this side as well. So, see, I put the first one in. You have to get this one as well. And there, hopefully. There it goes. Oh, come on. There's one too much, there's a double one in there. I get them out, so it was what screwdriver. There it goes. Get that one off. Get that one in. You have to knock it a few times to get it really together. I do it on the floor because I don't hammer too hard on the bench. Okay. Oh dear. Okay, do it once more, get it straight. Okay. Oh. Okay, that should be it, guys. So get the mounting of that transformer, and then we put that together. And we're nearly there to wire the thing up. Get this out of the way. There we go. Our little bolts. That are our mountings. What's that transformer? Four bolts, 4 nuts. Oh dear, here's a short one. See what it if this is not long enough. We'll get the other ones. The man made a mistake, no doesn't matter. I make mistakes myself, so. Okay. That should be here. There's more of that stuff. Okay. And a whole box of that stuff in there, so there we go. Get another bolt and that should be alright. He's a very nice chap, the man of that transformer factory. He's always very helpful, and I'm very pleased with people like that. So we put that in there like that. There's always a joy if you meet somebody who really wants to help you. I appreciate that very, very much. There we go. Put those little nuts on there, like that. There's always a fill, guys, but you have to put up with that. That's part of the job. But if you are interested in making transformers, just drop me a line and I will inform you how to do that. And if you have a factory or a nice man who wants to help you, I missed one here. Won't you believe it? You see that straight away. I missed one here. I have to take it off again, guys. No matter. Oh dear. I missed one here. Even at the mountains you notice that it isn't right. So I have to get my one in. Put that down a bit. There we go. Just tap him a little bit. Get the holes lined up and put the bolts through again. Ah, come on. If it doesn't go, you screw them in there like that. It goes into this place. Sometimes that happens, guys, because of one of the pieces of metal are not properly in place. Then you find that it gets difficult to get them in. There we go. Do our bit again. Okay, I tighten this a little bit. Put them on his feet. Get one of them in there. Have another one. Out of it. Right. Oh no, I have one. Getting ahead of myself. Okay. The other thing you have to bear in mind, you have to be very careful with that thin wire that breaks off quite easily. So if you bend that back and forward too much, then you will find that you won't get it, the wire breaks. So you have a point here but it doesn't go through. You see, when I screw it in like that, there's always something that is not lining up, so that doesn't really matter. I do it that way though. There we go. So we have 2 bolts on each side. Even then, this is a shorter one. Oh, okay, no matter. Obviously they have more sizes there in the factory, so you got them mixed up somehow. No matter. Anyway guys, it's a very nice factory we have there. They recently they moved to another location, and yeah, you can't think anything of any transformer they don't have. Absolutely, I'm very impressed what those guys make. Absolutely, it's absolutely incredible what they make. They're really good material. But then again, they have to be good, aren't they? If you see they make them by the hundreds, and I'm making by the ones. Hey, it's funny, isn't it? Yeah. Okay, there you go. I wanted to show you this because, well, you can put the transformer into its place, but you don't really have any feeling how this is going or how it is being done or whatever. So what is involved to get a transformer like that. Tighten them up a bit. And that's just going to twist and turn, so I get my pliers, hold that nut in place and try to turn again. See, this also determines how much it's going to hum. And the factory they have a resolution for that. They put them in the bath with lacquer, and the whole shebang gets soaked with lacquer, so they just can't hum anymore, so they are absolutely quiet. So well, he suggested to me I could come along and you could do that, put them in there, and that's very nice of him anyway, so I'm very appreciative of that. But I have to drive about 50 miles, or what is it, 40 miles, to get to the factory, and now this 40 is 18 miles driving just to put this thing into soak, so that is not long, is it? There you go guys, I wanted to show you this. I will shut down again and I'll come back to you when I have them in or whatever we're done, okay? Okay guys, it's just a couple of minutes further, so I was thinking just as well do a test of the transformer, see what comes out of it. So I'm going to Dremel a piece of strip to put the contacts on. Come on. A lot of dust. Yeah. Let's have a look if this fits. Yeah, it does. How about that? How about that for an eye, eh? Put the bag in. A carpenter's eye, eh? Okay, there we go. Just put some double-sided tape on that to stick it down. Just get my hands dust free. Get a cloth. Get it off. Otherwise my tape won't stick. That's it. Okay. Oh dear. There's always a bit of a fiddle, guys. Doesn't matter. We're having fun. Put that on there like that. Cut ourselves a piece off. Another piece on there. Cut that off as well. There we go. We'll take our strip and press it down. Now then. Oh dear. Now we have enough to mount it. Let's cut this off again. Put that back in this bag. Doesn't dry out. Okay guys, what I'm going to do next is the solder on those little wires, and we put the lead onto it and put it onto our separation transformer, and then we're going to measure the voltage on this. Okay, so I shut down for a minute and then I'll come back to you when I'm going to show you. Okay. Alright guys, I can put the light off. I think it will blind the camera. Okay, I'll just strip the wire from the lacquer, so I have to be with a sharp knife. You have to be very careful, otherwise you damage or breaks the wire. So I'm going to solder that down now. Get this properly soldered yet. That is the primary in this side. As you can see, the transformer has not been tested yet, so we're going to do that on camera, and consequently that will be also the last bit you will see in this part, in part 9, unfortunately. As I had hoped I would be able to show you everything in the 9 parts, but as it shows that I won't manage it because of the time it takes up. So the secondary, this. Yeah. Always say don't rush it. Do it properly. Take your time. Come on, you. My light is not very bright here. I have 4 lights on the ceiling. There is a certain color temperature, so I put my camera on that color temperature. So if I use the other one, the camera gets blinded, and secondly, the color temperature is different, so that doesn't help, does it? Okay guys, so far so good. We don't solder this the filament wire, so I have to pitch a bit of wire here, cut that off with my pliers. That's it, away. That's gone. So we will strip this a bit because I have to make a measurement on that as well. Cut it a bit even. So that's about it, like that. So we don't have to solder that or anything, so we'll do that later with a little loop on there, and we'll connect my wires to that. Okay, they're quite strong, those wires. There's only 6.3 volts which comes off here, so this is 44 turns on this 6.63 turns per volt. You can calculate yourself now how many turns are on there. So there's 235 net voltage, 180 volts secondary, primary is 235 volts. So you can do it in the stage as well, 110 volts. only your wire will be a bit thicker because of the voltage you want to put in. So that's all. It will work on a 60 Hertz net from 110 volts, but you have to make a provision then. You have less turns, but your wire will be thicker because of the current what flows through it. So guys, so far so good. Now we'll zoom out a little bit now. Come on. So far as I get. Okay. See if you can get that into. No, no matter. I just put it a bit forward that way to get the camera a bit higher. On the back you see here the two light bulbs we're going to use. I put the thing on protect and I put it on 60 watts. I get myself some leads, hold on. I'm not going to use a normal net lead, just I'll use this for start, so it doesn't matter. Let's have a look we got here. That will suffice. We have a transformer. We can get the current up so far as we like. So it's on 0 volt at this point. We put it on protect. So I'll put the other lead in there. So, and there we go. Going around that thing. See, I have them on my hands, so there's nothing wrong with it, so it's not turned up yet. I'll put this on here. 234 volts. Okay. There we go. Now, you want to turn that up. He should be there. I can't hear him. I can't hear him at all. Let's see how much voltage we get on there. I think we have 235 on there. So we have alternated current. Let's have a look at the voltages on the. You can't see, can you? That is aside. Put that on there. Have a look at it. You can see this. Yeah, you can. Okay, so we have a look. It's 228 volts. We got here 173. I will go up a little bit. Get the 235. I must have the 235. 237, that's just doubled up. Now we miss them again. 180 volts. Yeah, see the transformer is working. And we got here. Oh yeah, we have to go lower voltage, eh? We won't see it otherwise. Yeah, okay. 6.8. Should be 6.3. If he gets on full load, he will drop down to 6.3. I always have a bit up because I have one winding more than I should have. I should have 44, but I have 45. So that gives you a bit more voltage. I have to put it back. You can't hear the transformer at all, so I did my job well. So yeah, this is depending on the load, I suppose. It is 235, but we can't say we can say this is okay. We put off protect. You didn't see the light bulb come on, so we have to see that now. 240 volts now. See, that is the current with what this gives you. And don't do that yourself if you don't know what you're doing, okay? See, I can afford to do that because I have the experience not only doing this sort of things, but I also have the experience having shocks. You can believe it, you won't believe that, what an amount of shocks I had in my life. Oh dear, oh dear, oh dear, and since then but then again you see this working, just disconnect this completely. So that transformer is working, you can see that straight away. So today you learned something, what you can do if you mind put to it. So if you want to know how to do this, I will drop me a line, I will send you how you do it. It's quite easy, you know. It's just you have to know, that's all. Only you have to have a winding machine. You can put that on the hand roller, I saw people doing that. But you have nice wound coils, you have to come up with something different, something more permanent. So you have to put some effort into it. If you don't want to do that, fine with me, it's no problem. But if you want to do it, if you do it properly, just do it right. So you see for yourself what the result it gives, and that is very satisfying to do this kind of thing, you know. Anyway guys, there will be a part 10, unfortunately. So I have to finish the box, so you can see this box. We have to get our transformer in. Let's get this out of the way, come on. Oh guys, that workbench, terrible. It keeps the stuff gets loaded on there, never cleaned up. You know what out. People who are working on a workbench or something like that, with tools or whatever, you know exactly what I'm talking about. So we have to see if we get them on here without squeezing that all. There you go, it will fit exactly there. Okay, it will fit on there. So we have to hear the other gentleman calling it, well, it's not stable enough. Well, he's right, they have to stabilize that as well. So we put something in front of this and solder it down, and then it will be sturdy enough. And when it comes, it will put some between there and that side, so it can't move at all. So anyway guys, that's so far so good. I will finish this part 9. It was a joy to have you on board. Thank you very much for watching. And if you like the video, give me a thumbs up, and if you want to subscribe, even better. So, and I will see you on part 10. Bye bye.